Okay, welcome back, EENG 360. This is part 2 of listing 1.3. In the first part of this listing 1.3, what we did is we created this component called EQ1, okay, 1-bit comparator, and then I wanted to extend that to a 2-bit comparator, EQ2. Well, there's no sense in going through all the SOP and the POS stuff. Let's just instantiate two instances of the EQ1. We'll give them unique names. We'll map the corresponding variables to internal variables of this project, E0 and E1, that are standard logic, and then I'll use an ANDing of those two. If the individual 1-bit comparators are equal, then if both of them are equal, E0 and E1 will both be 1, and I'll have an output of EQ A EQB equal to 1 that I can assert right here. Now we did that last time. Let's go back and check everything. Okay, I've got a green check mark there and a green check mark there. So now what I can do is I can add a test bench file to test this. So what we can do here is say new source, a test bench. Now I want a test bench, but I want to test on EQ2, right? I want a test bench on EQ2. Now when I create a test bench file, it says, hey, I see two components here, EQ1, EQ2. Which one do you want to test? Well, we already kind of tested EQ1. Let's test EQ2 now. Select EQ2. Next, finish. And it'll create me a test bench file. Now again, since I have limited real estate here in this video stuff, let me get rid of all my comments. Okay, and save things. And now let's kind of look and see what's happening over here. In the left-hand side, you have EQ1, which is your 1-bit comparator, but then you have EQ2 here, but that's made up of two instances of EQ1. Okay, but then what I'm going to do is I'm going to create a test bench file that's going to test EQ2 that's a function of two EQ1s. So now we've added a third file to our project called test bench EQ2. Now we got a bunch of errors, we're going to have to get rid of those. So if we go over here to test bench EQ2, notice it has a library statement, it has an empty entity block, and then the first thing you have to do is you have to declare the component you're going to test. Well, there's a declaration statement for EQ2. Okay. Now it makes similar variables to EQ2, but I'm going to prefix those with TB for test bench, and then I'm going to call this guy a test bench AEQB, and then there's no clocks, so let's get rid of that. Now here's where I actually instantiate this guy, and I call it unit under test, UUT. Okay. So I create an instance of EQ2. But the minute I create an instance of EQ2, EQ2 is going to create two instances of EQ1. Now the variables on the left are the component variables, A, B, AEQ. The ones on the right are your local variables, which are the test bench files. Okay, TB. Okay. And then I don't need a clock yet, so we can get rid of that. And then here's my process. Well, what we can do down here is kind of do the same thing we did before. Just come along here and I could say what test bench A is equal to. We'll make that 0, 0. And then we could say test bench B takes on the value 0, 0. And then I could say wait for about 20 nanoseconds. And then I'll just kind of hard code and repeat all that stuff. We'll just do a couple of them here. And I'll let you fill in all the possibilities. Now let's do that. Let's do 1 and then put maybe a 1, 0 here and a 1, 0 here. And then we'll copy that guy. And then we'll do a 1, 1 here. All right? Yeah. So we'll just do 4 values. Now you could, of course, with 4 bits, go through all 16 values. Okay, at this point right here, let's make sure everything's compiled. All right, let's go back EQ1 VHD. Let's check syntax on that. Okay, now let's go up to EQ2. Kind of have to go in the hierarchy order. And then, okay, that one hasn't changed. That's good. And then the test bench, let's compile that. Great, everything works. Make sure the test bench file is selected. Simulate behavioral model. Okay, we should get a simulation coming up here any minute. And there you go. All right, let's see. There's our simulation output. Scale down the window, zoom to full view. And let's see, zoom to full view here. Oh, it looks a little messy there. We're going to have to fix that. Yeah, so this picture looks a little hard to read, but I can explain why. The reason is we're doing 1 microsecond, which is 1,000 nanoseconds. So we're going from 0 to 1,000 nanoseconds, but I think in the code, how long did I wait? 20 nanoseconds? 20, 40, 60, 80, 100. Yeah, so each one of these ticks is 20 nanoseconds. So you could try to zoom in on here and kind of scroll back and play games like this, zooming and stuff, but I'll let you play with that. And if we kind of zoom in again, we got to scroll back and we can kind of see our data right here. Okay, and right here you've got, well, let's actually turn everything to binary and then turn this guy to binary too. Yeah, so when you both have 0 zeros, the output's asserted. When you have a 0 1 0 0, the output's not asserted. When they're both 1 0 1 0, the output's asserted. And then here, when one's 1 0 and the other one's 1 1, it's not asserted. Now, to kind of get a good picture, try to map all your stuff such that you go to 1 microsecond. Then that zoom to full view actually works rather nicely. So what I could do is go back to here and change this guy to, yeah, if I did it to, well, I've only got a couple of them here. So let's just do 100 nanoseconds, and that'll take me up to, yeah, you kind of have to play games on the simulator here. So now I've accounted for 400 nanoseconds. And let's put a few more into there. And we'll just make that a 0 and then make that a guy a 1. So now I've got like about 600 nanoseconds worth of data. And then if I compile my test bench, simulate it, I'll get, I'm not using up the whole 1 microsecond, but I should be using up a good portion of it. And let's see, zoom to full view. And there you go. Yeah. So again, we can kind of change the radix to binary. And yeah, so when they're both 0 0, you get a 1. 0 1 0, nope. 1 0 1 0, yep. 1 0 1 1, nope. 1 1 1, yep. 1 0 0 1, no. And then you can kind of play the same games too. You can go back to your component TBEQ2, and here's your unit under test. Okay. If I right-click that guy and add to waveform, look what it did. It added all the variables of my component. Now notice it actually had traces for A, B, and AEQ. Now why is that? Well, because we've connected the test bench A to A. So A is going to be the exact same thing as test bench A. And I connected test bench B to B, so they're going to be the same. And then I've connected test bench output to this guy, and they're going to be the same. But I don't have values of E0 and E1. Well, I can get that by coming up to here and clicking, I think that's, was that restart, and then run the simulation and zoom to full view, and now I get values of E0 and E1, which are internal variables. Okay? But now also, if we come down to here, and let's see, I wonder if I could play the same game by clicking on this guy. Add to waveform. Yeah, there you go. So now I've got the variables inside the EQ1 component. I0, I1, EQ. But notice these guys take on the values of probably which one of those guys. Yeah, that's the first instantiation. You could actually put both of them in there. If I click that, add to the waveform. So now I'm getting a whole bunch of waveforms. And then if I play the same game, restart and run again, I can see every single variable in my simulation. And again, notice over here you have I0, I1, EQ, P0, P1. But also you have I0, I1, EQ, P0, P1. These are the two instantiations. These are the of the EQ1 component. And you see all their traces. You see the traces of EQ2 and you see the traces of the test bench file. And you can troubleshoot your system. So that's kind of slick right there. All right, I think I'm going to stop on that one and call it a day.